how would you define AI engineer or AI engineering?
Yeah, so before when you wanted to build machine learning applications, you need to build your own models. So that means that you need your own data and you need expertise in how to train a babysit a model. However, nowadays, if you want to build an application leveraging machine learning or AI, you can just send it direct API calls and have access to this wonderful capability. So that's really, really lowers the entry barrier to people. You don't need data anymore. You don't need a fancy AI degree anymore. It's a shift of focus from less machine learning and more engineering and more product.
Chip Huyen is a computer scientist and writer and author of the book AI Engineering. This book is currently the most read title on the O'Reilly platform. Previously, Chip was a researcher at Netflix, a core developer of NeMo, NVIDIA's GenAI framework, ML engineer at Snorkel AI, and founded and sold an AI startup called Claypot AI. She taught machine learning system design at Stanford, and her current book is the second one on ML and AI engineering. It's safe to say she's one of the most read ML engineering and AI engineering experts in the world. In our conversation today, we cover what is AI engineering and why does it feel a lot more full stack than ML engineering did? What are typical steps to build an AI application, from choosing a model through using RAG all the way to fine-tuning? What are practical ways for software engineers to get started building AI applications? And a lot more on this very timely topic. If you enjoyed the show, please subscribe to the podcast on any platform and on YouTube. Thank you. This greatly helps the show get to even more listeners and viewers. Chip, welcome to the podcast.
Hi, I'm Chip. I'm very excited to be here. So I've been following your Substack for a while. So it's really, I was really looking forward for the chat.
So first of all, I really wanted to congratulate you on this book. I've started to read the book, so I've not read the whole thing. I have started with some chapters and I went deeper in others. And what I found is when I looked at the table of contents, I was like, well, this looks okay. In terms of it'll span a broad sense because it goes from how do you understand foundation models, how do you evaluate them, what is prompt engineering, and you go into things like fine-tune RAG, fine-tuning dataset engineering. But then on each of those sections, it just starts to get initially there's an introduction, but it starts to then go deeper. So for example, for evaluation methodology, here, I'm just looking at the table of contents, but I start to read this. It's we know it's important to evaluate AI models. We know it's harder to do, but then you go into things like AI as a judge or ranking models with comparative evaluation and challenges of it. And then it goes, that's where some parts, in my sense is that I had to slow down. I had to look things up. So it does go really deep into a lot of these sections, which I found very refreshing, that it's got a mix of breadth, but it also goes deep. So this is definitely not a fast read for me, but it's one of those things where I'm just going to keep coming back to it.
Thank you. It was not a fast ride either. It took quite a while and a lot of references. I think I also published so I think in the book I cited about over 1,000 references. I actually read even more papers. I've gone to a lot of code bases. I have a tracking of 1,000 repos with at least now 800 stars now on GitHub stars. So I went to a lot of those code bases and a lot of blog posts, other books from the 80s, from the 70s, 90s to understand AI. So I also published this at least about approximately 100 reference links I found really, really useful for me in the process of writing the book. So if you just want to look at those references on their own, it's on my GitHub.
Yeah, and I was surprised with some of the really original research. It's not just I wrote about these papers or here was what I read, but as you mentioned, the 1,000 repos, you actually have a paragraph or a section about how did GitHub repositories change over time, the ones that were about infrastructure, AI, application level, other things. And you actually have more than 900 repos mapped out. I never saw anything like that. And clearly that was you, kind of slicing and dicing and doing your own kind of research.
Yeah, I feel I have this thing, I do a lot of manual labor. I do think I get a lot of value out of doing things in non-optimally. I feel a lot of people focus on what is the quickest way to do it? What is the fastest way to do it? But sometimes if you're willing to put into effort into things that a lot of people are not willing to, I feel you can get some kind of insights that other people don't get.
This episode is brought to you by Swarmia, the engineering intelligence platform for modern software organizations. Swarmia gives everyone in your organization the visibility and tools they need to get better at getting better. Engineering leaders use Swarmia to balance the investment between different types of work, stay on top of cross-team initiatives, and automate the creation of cost capitalization reports. Engineering managers and team leads get access to a powerful combination of research-backed engineering metrics and developer experience surveys to identify and eliminate process bottlenecks. Software engineers speed up their daily workflows with Swarmia's two-way Slack notifications, working agreements, and team-focused insights. You can learn more about how some of the world's best software organizations, including Miro, Docker, and Webflow, use Swarmia to build better software faster at swarmia.com/pragmatic. That is swarmia.com/pragmatic. This episode is brought to you by Graphite, the developer productivity platform that helps developers create, review, and merge smaller code changes, stay unblocked, and ship faster. Code review is a huge time sink for engineering teams. Most developers spend about a day per week or more reviewing code or blocked waiting for a review. It doesn't have to be this way. Graphite brings stack pull requests, the workflow at the heart of the best-in-class internal code review tools at companies like Meta and Google, to every software company on GitHub. Graphite also leverages high-signal, code-base-aware AI to give developers immediate actionable feedback on their pull requests, allowing teams to cut down on review cycles. Tens of thousands of developers at top companies like Asana, Ramp, Tecton, and Vercel rely on Graphite every day. Start stacking with Graphite today for free and reduce your time to merge from days to hours. Get started at gt.dev/pragmatic. That is G for Graphite, T for technology.dev/pragmatic. So one thing that is a little interesting about this book, it is about AI engineering. And this field moves so quickly. Like just in a week, we've now had a new model come out, for example, DeepSeek, that people are talking about in a few weeks. How did you write this book? How were you able to write a book about such a fast-moving industry so that by the time it's released, which was clearly a few months after you finish it, it will still be relevant?
That is a great question. So when I started writing the book, I was thinking the same. I was like, is now the right time to write it? Because there's so many things are still changing. But then I started when ChatGPT came out, like a lot of people, I had this existential crisis. I was in a group chat and I was just like, oh no, what does it mean for us engineer? I feel like there are two things that I usually identify with. One is being an engineer and the other is being a writer. And guess what two use cases that AI is really good at, writing code and writing, right? So it was oh shoot, well, what does it mean? So I started interview a lot of people. I started reading so much, and I talked to a ton of people, and I started making a lot of notes. And as a process, what I realized is that while a lot of those things that seem new, a lot of the fundamentals have been there for a while. So for example, language modeling is not a new task. Claude Shannon introduced that back in the 1950s. Or as a time we'll talk about RAG, right? RAG is actually not new. Is based on retrieval.
RAG is in retrieval augmented generation, right?
Yeah, and retrieval is a very old technology. It's powering, it's already powering a lot of use cases on the internet. Search or recommended systems and vector databases have been around for a while, and vector search is a very have so many cool algorithms already. So I kind of said, okay, first I said a lot of things that are new. And the second is that I try to focus on when I try to focus on asking the question okay, if this so sometimes it was oh, there's a problem with this, there's a solution to this problem, and I ask the question of whether this is due to fundamental limitations of AI, or is it just due to the temporary capabilities of AI? And I try to see okay, if it's due to something of of the recent current capabilities, how fast is that capability changing, right? So for example, in the early days, a lot of people have shared a lot of prompt tips. For example, you try to price the models, right? Hey, say if you answer this correctly, I'm gonna give you $200. And or we talk about prompt robustness, how robust is a model to prompt perturbations. And then I was reading about it, and I found it's actually models is getting more and more robust to prompts. For example, we saw of from the GPT 3.5 compared to GPT 3, it's already so much more robust. That means that the small changes to prompt actually reduce to a lot less variations in model performance. So this kind of thing, I felt it's probably not gonna stick around. So it's those kind of tips are not gonna be very relevant in the future.
So already when as people were still like, this was at the height of people were saying there might be a job as a prompt engineer. So you already saw this is likely trending down. Do I understand it correctly?
So I do think that's like just try. So writing, I think it's like a score is like making a bet. Like when you write a topic, you're trying to bet on whether it's gonna stay relevant in the future. So I think it's the people who have been trying to like looking at like progress and trying to like see like what it's gonna be in like 1 or 2 years from now on. So for example, another example is like context length. So at that point, I was like, okay, we want long context length. But then I kept seeing people were going really, really fast, right? From like 8,000 context length to like 128, like in a few months. It's like super, super fast. So it was like, okay, maybe the question is like less about like context length, but like context efficiency. Because it's like, can a model use a context efficiency like really, really well? So like there are certain, so like those are like kind of the bet. And I do think that there are certain changes during the process of writing the books that made me feel more confident in the bets I made. Or like another things like multimodality. I do think this like when I wrote about multimodal back in 2023, people told me that like you're too early. Everyone was still working on language now. We're not there yet. But it was just like, yeah, it's just like inevitable, right? Like I think like we learn how to work with language, but like I do want to do a lot of stuff with more than just language. And I think it's just like, and nowadays just everywhere, like almost all models nowadays are like multimodal.
So the title of the book is AI engineering, and we also now have this term of AI engineer. It's spreading like wildfire. How would you define AI engineer or AI engineering? Because I feel it's a little bit of a loaded term these days.
It is. I feel like a lot of terms nowadays are loaded. Like you're not allowed to use agent anymore. You're not allowed to use like a lot of things anymore. When I was agonizing over the title for the book, because people was like, first I know that we need a different term for machine learning engineering. And the reason is that when with foundation models, there are a lot of fundamentals or like systematic approaches that are still the same as machine learning engineering. There are a lot of new things. So for example, one thing is that before, when you wanted to build a machine learning application, you had to build your own models.
Just to be clear, you're comparing it with machine learning, right? So like what machine learning engineers did versus what AI engineers are doing.
Yeah. So just trying to explain why we need a different term for machine learning engineer to describe what we are doing today. So before, when you wanted to build a machine learning applications, you need to build their own models. So that means that you need your own data and you need like expertise in like how to train and babysit a model. However, nowadays, if you want to build like an application leveraging machine learning or AI, you can just like send it direct API calls and have access to this like wonderful capabilities. So that's like really, really lowers the entry barrier to people. Like you don't need data anymore. You don't need like a fancy AI degree anymore. A second thing is that like before, right? Like you need distributions because you deploy machine learning application as part of the existing applications. So first of all, if you build a recommender system, you need like an e-commerce website so that you can have like recommend or like some kind of website, right? Like so it's deployed as part of the application. Fraud detection is part of like maybe in a banking applications or like some kind of like payment app. But however, now you can just like put it out as standalone applications, right? You don't need an existing distribution channel, but like having a distribution channel is like really, really useful. So I think that another very big thing is that is a shift of focus from like less machine learning and more engineering and more product. So before, right, like you start from if you're a good machine learning engineer, you start from data. Like you have to gather data. You maybe have like human annotations, and then you train a model. And now once the model is good, you deploy that into your product. But nowadays, like you actually start with a demo, right? So you have a cool idea. It's like, okay, let's just try it out and see if it works. So you start with a product. And after you say, okay, that's like, it works pretty well. I want to make it like better, right? So you started gathering more data, maybe like with like as more of like prompt examples. or like in very rare case, I don't recommend most people do it in the early days. It's like fine tuning, but it's very rare. But like basically, you start getting more data, maybe for evaluation, it's extremely important. Like having good evaluations become even way more important with AI engineering. So you got data, and then after that, it was like maybe you've been like sending a lot of API calls to like OpenAI and Anthropic or like Google, and we're like, okay, now it's too expensive. Now I need to like develop my own model. So you start like hosting your own model using some open source alternative or like fine tune a model. So like before machine engineer, right? You go from a data model to product, and now with engineering, you go from product to data and to model. So it like it places a lot more focus on product and data, which will be a competitive advantage when everyone shares the kind of similar base like AI capabilities. So I do think that there's need a different term to separate it from machine learning engineer. And I didn't know like what terms you use. And then I was like, okay, let's just ask the people. So I surveyed like a bunch of people I thought was doing what does this building applications on top of foundation models. And almost everyone was like AI engineering. And I was like, okay, if that's the case, then just let's go with AI engineering.
So do I understand correctly that, the biggest difference is that machine learning engineers did a lot more kind of groundwork, getting the data and building the model, whereas AI engineering, you have a lot of that, at least initially. You can start either as APIs or something. So there's more of engineering. You kind of hack things together, you put it together. And then over time, as things become more serious or your product is bigger, you do a lot more of you might build your own model, or you might host it. You might one day even build your own model if it's there, but it's just a lot later. So like a lot of ML engineering comes down the path if it's big enough, if it works, etc. Whereas with ML engineering, it was the other way. You had to put in all this effort and then see if it even works.
So first, I feel like every companies may have different definition of the role. I think it's like even the same company, right? Like people with the same title, same role can do very different things. So it's not never like a clear cut definition. Second thing is that I don't think the question is like machine learning or AI engineering. In the vast majority of generative AI systems I have seen, there are very strong traditional machine learning or classifier component. So like imagine you're building a customer support chatbot, which is like whenever I ask at a conference, I see like a lot of people raise their hand. They're very, very classic GenAI applications. And so you get a request from a customer. And maybe like you have like several different potential solution for it, right? Like maybe if it's an easy query, you might send it to a cheap model. Or if it's like a harder query, you might send it to a more expensive model. But if it's something that's very sensitive, like, hey, why did you charge me twice for the bill last month, right? Then you might want to send it to a human operator. So you might have this on like a router or like an intent classifier. And like to choose what you send it to, which is like a traditional classical machine learning model that you can build. Or like after you get a response from an AI model, you might think it's like, okay, does this contain like PII? So you don't, because I don't want to send back to users like responses that contain like private information. So that like PII detections can be, or like toxicity detections can be a classifier. Or in the RAG system nowadays, like we talk about like how a lot of it using retrieval systems, which are also like, I think it's like in the realm of like classifier, like classical machine learning that you can build yourself.
So what are the most common techniques used when building AI applications? Things that, the software engineer who's going into building AI applications, I should know about, and later I can go deeper into.
So the assumption here that you have like tried a lot of solutions, and now you try generative AI, and you think this generative AI is a solution for you, and it thinks like, what is the first, like, what should I progress from there, right? Is that correct?
Yeah. It's just like, what are some common approaches? Like I think things like RAG, fine tuning, or other things that are just good to know about. I should probably learn more about those topics.
Yeah. So I think like those techniques are useful. And I was usually recommend some development, or like not recommend, but like a common pattern I've seen is a certain developmental path. So initially, the first thing I would say is like trying to understand like what means a good response, what a good response is, and what a bad response is. So like what you want the model to generate. And it's not always intuitive, right? So for example, like LinkedIn has a very great example. So they built a candidate like job fit assessments for candidates. And they found out that like a majority of their time spending just to understand like what candidates needed from the model. So initially they focus on it correct, but then they realize it's like candidates like found it not helpful. Like say like if a candidate asks the model like, am I a good fit for this job? And the AI respond with, you're a terrible fit. Then the candidate was like, okay, well, when am I doing this information, So you need to like try to understand like, okay, here is they want more like understanding what are the gaps and how they can fill the gaps, or like get suggestion for other roles that are better fit for them right now. So like have this like a pictures, like clear understanding, and then build a guideline. Like, okay, given this response, answer like this, like be helpful, show them like the gaps, or like show them the role. Like have very clear guideline for the model, like in the prompt. So you try those prompts, and then you look at the output, and then maybe you can try to add more examples. And then just like go through like get really good response and try to evaluate. Maybe like have curate a set of queries and like experience responses using both automated metrics like as a judge and also like human evaluations to measure the progress. So like you have done prompting, we have like added more examples just to the prompt, and maybe you will like start like make it more complex. So you may use like you can give them the model more context so they can answer better questions, right? So maybe when our users ask a questions, you can like have the model pull out like all the documents or all the job listings related to this question, or information about the company, or like get a candidate resume, right? So you build a system like you augment the context with the document. So that's a RAG pattern. So I do think that like RAG is a very, very powerful pattern. It's nothing really, really fancy. And something interesting about RAG is that a lot of people equate RAG with vector search, right? Like when I see a lot of people like, oh, I want to use RAG, and here's like what vector database I should use.
Oh, so like people jump straight to vector search. Well, yeah, because you do have the chunks, like the embeddings can be stored as vectors, right? So as engineers, we're like, I need a vector search database or vector database.
People love databases. That's very interesting. But I feel like the first solution is probably not like jump straight embedding based retrieval, because you have to use. You need to build like an embedding model. Like the quality is that really highly dependent on like, the quality of embeddings. If you have bad embeddings, you obviously retrieve things well. Also, like vector databases can be quite expensive to run, and then add latency. Also, another thing is it's like vector databases can like embeddings can also like obscure certain keywords. For example, if I'm searching for like a specific error code, right? Like through embedding, you don't really get the exact error code anymore. So there's certain challenging with vector databases and vector search. So I think it's like the usual like common approach. Like maybe just start with something as simple like keyword retrieval. Like if you ask, like just extract all the keywords from the user query and find all the documents that with the queries, and you say, okay, maybe the documents are too long, and now I can't fit into context, right? That's when you start with chunking. Okay, now how do I chunk this like documents into context, like they can fit into the context length? And now with chunking, you have like other problems, right? So for example, like you have maybe like the keyword, like the document is about the company X, right? But like people say, from now on, company X is referred to as company. So like it's a rest document, you don't have X appear anywhere. So you don't get the chunk. Like if you search for X, you don't get the chunk like below. So you might want to like, okay, now I need to extract the keywords from documents and like add metadata to every chunk, or like get the title of the document, or like some people like started adding summary to it, or like Anthropic has a very, very good article called like contextual retrieval. It's like they ask ChatGPT to generate the key information metadata about like each document and append that to like, or like prepare that to each chunk to have you retrieve the right chunk. So I do think just like having data preparations right actually give a really huge performance boost. Like I have seen that's like giving way, way better performance boosts than focusing on like which better databases I should use, So what is a little bit of like, I'm not saying that they're not useful. It's just like, in the beginning, you probably want to try something simple, like with the biggest performance gains. And then you started moving up like the complexity level. Also, like for a lot of retrieval, someone told me very interesting quote, a little bit of like hot takey, but he was just like, I'm not going to take any retrieval system seriously if they don't benchmark against BM25. So BM25 is a pretty old school, like 20 plus year now. Retrieval is a lot simpler, like term-based retrieval, not embedding. And it's a really, really hard to beat retrieval systems. And I think a lot of time we use it like, if you start a complex, you can like now combine like both term-based retrieval and like simpler solutions with like vector databases. So you have both the semantic, like on the embedding side, but you have both the term, like exact keyword match, like on the term-based. So a lot of things, the hybrid search is very common. So we talk about like prompt engineering, add more examples, RAG, right? And I think after that, maybe have to max out on a lot of those things, which usually take a while for people. Like maybe then you might consider fine tuning. But I think like it usually like have a lot of reservations against fine tuning. Because like fine tuning has like a whole host of like new problems that you need to deal with. Yeah, like fine tuning, like first you need to think of like, now you have this model, you fine tune, and now you need to think of like how to host it. And like, a lot of models are big, like they're billion of parameters, right? Like they are not easy to serve.
I actually read this part in the book. You actually go into the details of the problems with, the memory size and also like you cover the alternatives where you might not need as much memory, but they also bring other trade-offs. So it's trade-offs within trade-offs within trade-offs, right? Like you're starting to solve one problem, but you're going to get a bunch of others, and you'll need to decide, is it worth it? My time, effort, resources.
Yeah. So I definitely think that also like when you fine-tune a model, you kind of own the fine-tune model, and now I mean like you the question is like, how do you maintain it? Like anything, so we have this whole world of very smart people developing new models, so like this capability increase like rapidly. Like, so when you have how long can the fine-tune model like outperform like those new models that we're putting out? So you might spend a lot of energy and effort into fine-tune a model, and then just a week later, maybe like some like, I don't know, random Chinese company you never heard of release this like extremely fast and strong model, right? So it's quite challenging. So fine-tuning you think is like the last resort, not the first line of defense.
Yeah, but what I've heard is basically like, if I got it correctly, like do a structured approach, like, start with prompting, start with simple, start with you getting responses that make sense, then add more data. You can do this with, RAG. You can do it with chunking, keyword extraction. Data preparation really, really makes a big difference, which a lot of people don't think about. And then you can go to more advanced things. There's a whole host of things that you could do. But my understanding is you're probably saying like, you'll probably get there over time, but initially, these things will keep you busy, and you'll probably be able to build a pretty good system just with the basics and a little bit of engineering and most importantly, understanding the problem that you're trying to solve, as opposed to building whatever shiny technology or approach.
Yeah, also like the approach can also be different for like individual developers or like enterprise, like if you look as a whole organization. So one thing I haven't seen is just like for, especially in the early day technologies, usually like enabling new use cases actually bring more returns on like just like incremental improvement over existing use cases. So like maybe like if instead of like spending the effort into like investing a lot of energy getting like etching out like a little bit of performance with like fancier like complexities, maybe like using the stack you have had and like opening up like new applications. So so I say like that's why I feel like a lot of companies will take a while to get to the fine-tuning phase.
Trust isn't just earned, it's demanded. Whether you're a startup founder navigating your first audit or a seasoned security professional scaling your governance, risk, and compliance program, proving your commitment to security has never been more critical or more complex. That's where Vanta comes in. Vanta can help you start or scale your security program by connecting with auditors and experts to conduct your audit and set up your security program quickly. Plus, with automation and AI throughout the platform, Vanta gives your time back so you can focus on building your company. Businesses use Vanta to establish trust by automating compliance needs across over 35 frameworks like SOC 2 and ISO 27001. With Vanta, they centralize security workflows, complete questionnaires up to 5 times faster, and proactively manage vendor risk. Join over 9,000 global companies to manage risk and prove security in real time. For a limited time, my listeners get $1,000 off Vanta at vanta.com/pragmatic. That is VANTA.com/pragmatic for $1,000 off.
So let's say that at my company, we decide to build an AI solution, and let's take the example that it's going to be customer service automation. What are typical approaches that I should know about? And you do cover some of these things in your book as well, like some of the kind of more common steps that I'll need to take.
So customer support solutions. So I would say it's like the first thing I would look into is just like what are the bottlenecks for the solution right now. So for example, like I have worked with another startup I work with. It actually has this challenge. They had a lot of like customer support requests and they don't know how to answer. And the solution is very interesting. It's just like, okay, let's try to drive a lot of questions into the common channel, like public Discord. So that means that like other users can also help answer the questions. So like as much, and also like in the future, if someone have a question, right, they can just like refer to previous discussions instead of like asking you. So like they try to make a lot of the discussion customer support requests public. So like another solution was pretty popular in like in 2018, 2019 is that you do like routing to the right department. So the challenge then is like they realize the bottleneck is in like triaging. So like first when we get a request, I don't know which department to send it to. So there were a bunch of startups then. It's just like, okay, let's try to build a system like to predict like, should it go to like the finance department or should it go to like a technical support department? Like just kind of routing already reduce like the friction a lot. And if you think it's like, okay, when we need like GenAI to do it. So I think I really recommend the frameworks that Microsoft introduced. The code is like cron, walk, run, like going from like a slightly lower stick to like higher stick deployment. So first of all, customer support chatbot, right? So maybe initially you can like have a human in the loop. So for example, you can have like for every request, instead of like a human agent writing the response from scratch, you can have like AI suggest like a few options, and like the human can choose one, or like can just like choose one as a starting point and then make short quick edits and send it. So like once you see this like, okay, maybe the acceptance rate is like getting really high. So first of all, for these categories of queries, maybe the acceptance rate is like 90%, right? So you may feel more confident to like roll it out. So maybe roll it out to maybe a smaller users, or you can roll it out to even like internal use cases. And then, so like you give it more automations, but like reduce the scope of like, of deployment. And then after you're really happy with it, you can like roll out to like, more users. So yeah, so that's how I would go about, something like customer support chatbot.
Nice. Cause what I was kind of expecting you might say is like, oh, just build this like, AI framework, deploy it, see it. I feel that's what a lot of companies are doing, by the way, or a lot of teams is like, oh, Gen AI. Oh, let's get, this model from ChatGPT or Anthropic. Let's try to, put it there and let's put it out there. But I really like how what you're saying sounds like it's not really like, what you explained, it's not really specific to Gen AI. That you went through like, look at the business problem, look at the problems you have, look at the options, which include not just Gen AI, but more traditional machine learning, as you said, classifier. And then you look at if, these tools help your problem, and then make sure that it actually solves your problem when you roll it out. Don't just blindly roll it out, which, I mean, all of this sounds to me, it's not really new, is it? It's not like... you could have said the same thing 2 or 3 years ago before Gen AI, except we would have not had those Gen AI tools to play with.
Yeah. So I think actually before our chat, I should look up one of the talks before, and you have this talk about like things that haven't changed, like things that feel very similar about software engineering. And I definitely like dealing with a new technology is one of the things that never change. So I feel like every time there's a new technology that comes out, I can hear like the collective sigh of like senior engineers everywhere saying like, not everything is a no. Like people just try to get the technology to work for everything. So I do think that a very common challenge I see is that like people just like jump straight into it. Like they just want to use Gen AI for when they don't need Gen AI. So I think there's two different headlines. So one headline is like, I use generative AI, right? or in the other headlines that I solved the problem. So if you want to focus on the first headlines, and you generate AI, but if you want to solve the problem, then you need to understand like what is the problem? What are the challenges there? What's the roadblocks, and remove the roadblocks using the simplest solutions, not the fanciest one.
Yeah, I feel that there's a bit of a really strong fear of missing out across most tech companies, that everyone knows that this is such a transformative technology. It gives us so many new capabilities that it will be important. I think everyone knows that their company will be using it, but now there's a fear of missing out of, oh, what if my team doesn't build it? What if someone else gets ahead of me? And so like a lot of companies, many teams are all building it and, trying to just, like using a hammer looking for nails, even though they might not need it at the time. I'm not sure if this is a bad thing necessarily, because, people at least get experience with it and, they will need to learn about it. But it's a very interesting time because it's rare to see. Usually we see like, a new backend framework come out or like something that's limited to domain and people jump on it. But this is the first time I've seen that a whole industry is jumping on it and everyone is trying to use it and put it in, whether it works or not.
I definitely agree with you on this FOMO thing. I do think that's like everyone jumping on it is actually a pretty good thing. Like, I feel like the energy is incredible. I've never before seen so many smart people focusing on the same problem. It's like incredible and the progress is amazing. I do think, however, I think there's an irony. It's just like, the more we want to not miss out things, the more things we will miss. Because what I think is feel like if we try to keep up with news, right? We just try to jumping from one news to another, one piece of news to another. We will always stay at the surface level. We never really go deep into anything. So I actually don't quite read news. So I find it's a little bit distracting. So I think I try to I feel like my approach is okay, pick a problem that you care about. And then only care about things that's have you solve this problem. So if there's some news coming out and was just does this help me solve this problem? If it doesn't, I can't wait, right? Because I feel like if there's something important, it will still be important two weeks from now on, a month from now on. I don't drop everything. It's okay, let's just go and understand what it is. So I feel like trying to get a more, try to stay a bit calmer. Yeah.
Yeah. So when you're building an AI system, one of the things that you will come across is you need to evaluate the output, how well it works, does it solve your problem? Why is it difficult to evaluate AI systems, and what are common ways to do that?
So evaluation, I think, is $1 billion question, or even $1 trillion, given how much people invest in AI right now.
Nice.
Yeah, it needs to go big, if it go big, it better go really big. So I think it's challenging because the smarter AI becomes, the harder it is for us humans to evaluate it. So before, right, if AI was incoherent, you can pretty tell if the response is bad. It's okay, it doesn't sound good, it's a bad response. But nowadays, it's pretty coherent, right? For example, if you ask it to generate the summary of a book, if the summary sounds convincing, you actually don't know if it's a good summary or not, and you might have to read the entire book yourself just to evaluate whether it's a good summary. Or the math, a lot of time, I personally use AI to ask a lot of questions because I don't know the answer. And because I don't know the answer, I don't know if the answer is correct, right? So an example is a lot of people can tell if a math solution to a first grade question is correct. But very few people can tell if a fancy equations proof is correct. So I remember it's when O1 came out, Terence Tao. He's this amazing mathematician. I think it's one of the best mathematicians of our time. He actually took time to evaluate O1, and he says the experience of using O1 is similar to advising a incompetent but not completely stupid. A mediocre but not completely incompetent, BG student. But this makes me think of if we really need the brightest minds today to evaluate AI, then really soon to run out really, really smart people to evaluate AI. So I thought it's so what could be what would be the next step forward? So before, a lot of time we use a whole human as a gold standard for AI performance. It's like, okay, so humans like started writing out like, here is how you should respond to this, and here's how you should do it, and like AI should try to copy human. But now for many tasks, like we have AI like outperform like human way better. So I think like there's several. So I thought about like several approaches like to deal with it, and I think like that's why I separate the chapter like those. So initially I had like one chapter on evaluation, but the more I write about it, it was like, shoot, there's so much to it. And I'm going to two pretty long chapters on evaluation. The first chapter is on general methodology, and the second chapter is about like how to use like different techniques to like evaluate the AI system. So methodology, like one is that functional correctness. So it evaluates the output of application based on how well it performs as a task. So like if you say that like, hey, use AI to save energy, you can see like how much energy it actually save. Or like, hey, uses AI to play this video game, you can see like how high is the score you can actually get. Or a very common use case for this is coding. So I do think that's like, it's not a coincidence that coding is one of the most popular use cases, because like we actually know how to evaluate generated code. Like we might not know how to evaluate generated like essays and stuff, right? But you know how to evaluate generated code because like we've been testing like code for a long time. So with code, you can do like use functional correctness to evaluate like first like whether this code compile, does it run? Second, like does it generate expected outputs? That's what we wanted to do. So like that one approach. The second approach is like using AI to evaluate other AI. So we have been using AI to evaluate to automate a lot of applications. So can we also use AI to automate like evaluations? And actually like doing pretty well. I think we have is like I think like in many even back in like 2023, LangChain has this report. They saw that the majority of applications they saw already has like some sort of like AI as a judge, or like LM as a judge, and I think it's like it's growing. And we do things that's like it's getting like pretty cost efficient and like useful. But of course, I see a lot of like challenges around using AI as a judge that we can go into later. But another approach I thought was very interesting is like called like comparative evaluations. And the reason like as humans, it might be hard for us to give an absolute score on something. But if we can give like two versions of something, we can tell, oh, we like this one better. So then we have done a lot of studies showing that like even for tasks where AI is like outperform, like doing at a level where like humans experts like can't really do, we can still tell, like detect the differences. So I think it's been like I think this has been a lot that has been like guiding not just evaluations but also like model development.
Sounds like there's just no simple answer, right? Like you kind of need to go through all these options and figure out, like in your case, which makes sense for costs, for what you can do. Can you have a human in the loop? So there's no real silver bullet, no one thing that you can just use.
I don't think there is a simple solution. So that's one thing I'm a little bit skeptical about evaluation tooling, because a lot of challenge with evaluations are not because we don't know how to evaluate, but because it's required disciplines and hard work. And a lot of things it's like tools can't really automate. So for example, one thing for evaluation, like we need to evaluate an application based on what users want. And we don't, so that means that we need to like go and talk to users. We need to look at their interactions. Because a lot of things, what we think is like, we want to like evaluate what matters, right? We have to measure what matters. So for example, I have several examples of like how it's very counterintuitive thinking that we're measuring one thing, but users actually care about other things. So in the beginning, for example, like I have a friend who building a pretty big application, just like basically building like to summarize meetings. And initially they were like, okay, we try to measure like correctness, like does the summary cover the content of this meeting? Or like they also like think about like, hey, does the model follow the format, because they think this like users want like shorter summary, and they agonize over like, do we want like 3-sentence summaries or like 5-sentence summaries? And they try to measure though. But actually, eventually what they found out is that users like don't really care about the whole content of the meeting. People only want like, what is the action item for me? Like, what do I have to do after this, right?
Yeah,
so
yeah,
actually,
yeah.
so they start changing, like, so they don't measure correctness anymore. I mean, they just still like don't make up things, right? But they focus on like don't miss out on action items specific for the person asking for the summary. So it's like, or other examples, like some people using chatbot so we talk about a customer support chatbot. So we want to go back to that example. So a pretty big tax firm, so they build a chatbot. So tax software, you can pretty tell which company it is. So they was just like launch a chatbot and to help people with tax preparations. And the responses were like very lukewarm. They were like, so they were measuring by like the users how they use it, and it was like people just didn't really seem to use it. And they were like, why is that? Is that because it's like is what hallucinate, or like what is the challenge there? So they try to measure all those kind of metrics, right? But in the end, they found out it's just like users didn't use it simply because they hate typing. The people just like don't really like typing, and also like because if you're faced with a domain that you don't really know, like I use the software because I don't know a lot of things about tax. I don't even know what question to ask. Yeah.
Oh, so they didn't know what to type. They didn't understand the domain. They wanted a tax thing because they wanted to take care of their own their tax.
Yeah. So I think myself started like trying to like understand more like what kind of questions like people would ask and like suggest that in the beginning. And then it's just basically it's a guide users. So it's kind of like educations, like, hey, here's a question you should ask. And then here's the answers, keep going. So I think it's like, a lot of that is, it's just a lot of understanding your domain, the problem domain, like go talk to users, looking at the data. I do still think that looking at data is very, very important. I think Greg Brockman has a great quote about it. So he thinks it's like manual data inspections is one of the activities that has a highest ratio of like value to prestige. So that means that's like people don't think highly of like manual data inspection or data wrangling. Let's give it to some intern to do, like, let me think with something fancier like algorithms and stuff. But actually it's extremely high value because by looking at data, you detect patterns, you understand how the users use our product. So I actually like, I usually, a very good practice I really highly recommend to teams is like, don't forget human evaluations. So you use AI as a judge. But AI as a judge has a lot of challenges because like the quality of the judge depends on the underlying model and the prompt, and also non-deterministic. So things can change over time. But like if you have some like human evaluations, like very consistent, like very clear guideline, like every day, just go in there, look at maybe like 50 samples of like actual interactions, or like if you have more resources, go as high as like 500 or 1,000, right? So that you can like get some kind of like picture of how the users, like first how the users are using your product, any changes in behavior based on like current events, maybe because of reasons like administration change, maybe people have a lot more questions about that topic, for example, or like help you like correlate with like other automated metrics. For example, like if the AI judge score somehow like start changing compared to the humans just score, maybe it's just something you need to investigate.
Yeah, so I guess you cannot, like as you said, you can't really skip hard work if you want to get good results, and you can't really pull humans out of the loop fully, at least initially. What are some common mistakes you've seen when teams are building AI applications?
Common
I'm sure
mistakes.
you've seen a lot.
But I feel like I don't want to say in a way that everyone is an idiot. So one, I think we touched on several. So one very common mistake is like use GenAI when you don't need GenAI. So first of all, there's a startup that came with me with a pitch. It was like, we're gonna use GenAI to help people optimize electricity usage. So when I asked, like, so that people can tell the AI, like, hey, here's our, like, I live here, and here are the activities I do during the days that are very energy intensive, maybe like charging a car or like doing laundry or something. And the AI is going to tell you, like, hey, you should do this activity at this time and this time so that you can minimize the electricity bill. And they were like, our results show that, like, you can save you on average, like, 30% of electricity bill. And it was like free money. Why would anyone not want that? And so I was asking them, it's like, what is this cost saving if I'm just like manually schedule like the most intensive one during the off peak hours? Right. And I just like, like, okay, just charge the car at like, 10 p.m. or something,
Yeah.
And they were like, we haven't done that yet, but we're going to try it and let you know. And they never got back to me, and they abandoned the idea later. So I feel like a lot of those optimization problems can be solved like greedily, like maybe even like a spreadsheet
without
or like
GenAI.
Yeah, without GenAI. Another spectrum is that like I see a lot of companies giving up on GenAI because they think that GenAI is not good for their problem because they have tried it and it doesn't work. And in a lot of time, I got surprised. I was like, wait a second, I just talked to another company who just like they use that for the similar use case and it worked really well. And when we look into it, usually because of like bad product, like because they don't promise well, they don't understand the users, this is like they don't even know what to evaluate well. So for example, like I was working with this like companies that does basically like extracting resume information. So there's a person like get a resume and they try to like map out like where does a person work before and like create a summary of that person's life. And they have two steps. Like first, like from resumes, they try to extract all the text. And then after all the extracted text, they extract the organizations from the extracted text. So by the way, the resume is a PDF, not pure text, right? And then I asked them, so it's like, okay, it worked terrible. Like they never like they got like the organizations like wrong about like 50% of the time. And then I was asking them like, where in the process does this fail? Is that from the PDF to extracted text or from the extracted text to organization extraction? And they were like, oh, we don't know. We didn't do that. It was like, if you can't pinpoint it, if you can't localize where it fails, then how can you fix it? So a lot of times it just like seems like common sense, but somehow, I don't know, it's just something that's always like puzzle me a little. Or like another is just like start too complex. For first of all, like jump straight to better databases or like fine tuning. Or another common one nowadays is like when you see a fancy agent framework, you're just like, let's use this framework, let's just try it. And I think that eventually abstractions are like really, really cool. Like I think I'm really grateful for many abstractions that make my life easier. But I do think that abstraction should encode like best practices and should be heavily tested. But I think we're still in the phase we're still learning like best practices. And also like a lot of abstractions can introduce like unnecessary, very, very painful bugs. So when I was going through the code bases of a lot of those frameworks and I found out something interesting, like a lot of those frameworks have some default prompts. It can help you get started, right? Because it's like, it's make you very easy for you to like, to begin. But then like every single of those prompts I look like have some typos and they just like change. So you have somebody submit a quick PR to like fix the typos, but it's not part of the release anything. So if you're using like this framework, using one of the default prompts, and then suddenly the performance like applications just like change, you actually don't quite know like why is that changing because the prompt was like changing under the feed. So like those are very interesting. Like those are just like patterns.
But it's interesting like because what you mentioned, it sounds like if I'm, collecting these, it's like using this technology when you don't really need it, giving up on it without, just for common sense reasons. You could have just fixed some easy things, using a new framework when it's just not really high quality or it doesn't really have the best practices. This kind of all sounds stuff that we could just replace GenAI with, a new technology or a new stack, and we will probably hear similar things, right? It's typically these things because it's changing all the time. There's no best practices. No one really knows how to use it. There's whoever tells you they're the expert, they're still just they have a maximum year of experience with it. It's not really new, is it?
Yeah, I think I definitely agree with you. I do think that like even though like technologies change over time, there are like systematic thinking. It's like systematic approaches to problem usually don't change. Like, yeah, if you want to solve problems, you first start by like breaking down the problems, like seeing where the challenges are, and like go through different solutions to like do that. It seems common, but I think like a lot of time, a lot of us get FOMO. I think FOMO get in the way and was like, okay, we know that's the right thing to do, but I also feel like I just need to check this thing out first, and if you keep doing that like 3 times a day, the day is gone. And you just like never really get time to sit down and think really deeply about what is that you're trying to do.
Yeah, so I guess we're going to see a lot of the kind of mistakes that are with new technology happen. Plus, if some of the listeners have adopted new technology, you can probably use some of that approaches. I mean, just localize it for GenAI and see if you can avoid some of those.
Yeah,
Speaking of new technology, as someone who's learning GenAI, a software engineer who wants to get into AI engineering, what would your recommendation be to learn? Things do change so fast. You did mention the importance of fundamentals. What would you focus on?
I have a lot of thoughts on learning, because I like learning a lot, and I think over time I just like try to like observe some patterns. And like, by the way, like the way I learn things might not be the same as the way you learn things. People have different learning style. But in general, I think it's like, I think of learning has like 2 different approach. One is like project-based learning, and the other is like structured learning. Project-based learning is like, okay, you choose a project and you work on it really, like go and try and solve every problem in that project, right, and finish it. Where structure-based learning is more like when you take a course or you read a book. It's just like like somebody else laid out, like here's the things that you want to do. And I think there's quite a bit of a debate on like somebody told me recently that that like a very good friend, and he said like, he thinks a problem nowadays with people who want to become an engineer is that they spend too much time learning and not enough time doing. And he was just like, just forget on the courses, forget on the books, just pick a project and just work on it. And I do think that project-based learning is very, very valuable. But you think of like, here is a set of the skills and knowledge I want to do, right? I need to have to become like really good at something. Project-based learning can have you hit a lot of this point, but it doesn't always have you hit like on the point. And it can like sometimes you get the confusions. Whereas like sometimes you still need to complement with structured learning. And another thing that's like project-based learning, that a lot of people like usually do it, follow some tutorials. Like people like someone has this tutorial how to do this. And I think tutorials is a really cool. And I think like I also personally do it a lot. But I also noticed that it's very easy to just like mindlessly clicking one cell to another and just run this cell, run another, and don't really stop to ask like, why is this being this way? Like, why is this library being imported? Like, why is this code written this way? Why is the batch size is 16 instead of like 64? Like, why is there like only 8 experts and make sure expert? So some people, it's very easy to not stop. Like, there's no like mechanism to force you to stop. You just want to run to the end and see what the output are and make some changes, like by the best guesses. It's something funny, like, when I was like working on this like open source project, and I was like, I wanted to do a market research and like see who is using this framework. So it was a framework was IBIS, and I thought it's like, I knew that if you wanted to use this framework, you need to do like import IBIS, right? Yep. So I went through on a GitHub and I searched for all the repos that have the line like import IBIS. And then I found a lot of repos that I went to it. It has the import IBIS, but then it doesn't like the code base does not have IBIS anywhere else. Like, it's not used at all. And I was like, what is happening? So I realized that a lot of those repos like copy from a tutorial. Yeah. And that tutorial used import IBIS. And that's by mistake. And then like everyone else, so maybe the original developer like import IBIS and then deleted the code because it didn't use it anymore. And then like everyone who copied it just like did the same thing. So I feel like that is something a little bit dangerous. Like tutorial-based learning is great, but I do think it's very important to be able to stop and ask questions. And sometimes structured learning can help you like ask the right questions. Like think things through. So I think like for people who are starting, I would recommend maybe a mixture. Like yes, choose some project you want to work on. It doesn't have to be like big fancy project. Like just try to like pick one. And then at the same time complement it with like some structured learning, like pick whatever, like maybe a book or doing a course with your friends, read paper. I think read paper is a bit interesting, because reading paper is like, it's a skill. It can be quite time consuming, and you need to know like what you want to get out of it. But yeah, so like start a project, complement with like structured learning. At the same time, there's an exercise that I found very, very useful, at least for me initially, is that like for a week, I try to observe like what I do, like try to make note of like what I do, and try to think of like what percentage of that can be automated by AI, like what could be done by AI. Yeah, and then I try to use AI to do those. And it just gave me a lot of ideas on like on the use cases. Like just think about it, what matters to me, and maybe an application that can solve the problem. It's just great already.
Yeah, I think that's an unconventional way, but it's a good way to look at it, because in the end, also it kind of, I think it might help you get ahead of, this like dread of like, what would AI do for me? Because you realize what happens when you automate things, which actually leads to my next question. There's a lot of fear mongering around, AI will mean the end of software engineering, because AI is very good at coding. It's a lot better than a lot of other areas. What is your take on, as AI gets better, will it actually, end software engineering, or it will change it, or it's not going to much change actually?
I think it goes back to the question of like what software engineering is. So maybe you can get an analogy. Maybe you can help it explain it better. So the writing, right? So we tend to confuse the most salient activity of something as the job itself. Yeah. So first of all, writing in the past, writing means like the physical act of like putting some like words onto paper.
On a paper or...
And back then, right, like it was, people think of writing as that, and people actually took pride in the calligraphy. Like, I have beautiful handwriting, you must be smart, you must be intelligent, right? But then we had computers. And now writing doesn't refer to the act anymore. Writing refers to the process of arranging ideas into a readable format. And I think the same thing as coding. So now that people think like software engineering, people think of like it's a physical act of like putting code on like, I don't know, like a VS Code or like Vim or whatever software that you use. But that's not what software engineering is. Software engineering is about like solving problems. Like, here's the problems. How do I like come up with executable programs to solve this problem? Coding itself is just like a physical act of it. And I do think that's like, yes, maybe AI can have you automate coding, but I don't think it's gonna fully like automate like problem solving, because you still need to know what problems it, and only you can understand like what problems you're facing. Like,
and also, AI has the problem, like coding really, or software engineering really, is like, yes, you need to solve problems, but what I don't think we say is you need to do it very precisely. The reason the job software engineer or programmer exists is because it is very hard to be specific, to speak the computer's language. Because, if you move that if statement somewhere else, or if you change a variable, suddenly, the program crashes, because now you have a Stack Overflow exception, which you, of course, understand if you're a software engineer. But if this is just a business user who says, I want to show, if you resize the window, I want the button to move over. It's easy to say, but then as a software engineer, you know the edge cases, you know the environment, you know what you need to worry about. You need to worry about system events, etc. And then you write code for all of those things. And I'm sure we'll get to a point where the AI will be able to generate some of that, but it might not. And you will still at some point need someone who understands, that code and can figure out where the gap is. Because English as a language is not as precise as a programming language. Programming languages were invented to be very precise and unambiguous and very easy. You can go from assembly code to the programming language because it's a one-on-one mapping, and then from English to a programming language, that's very fuzzy, right?
Yeah.
So
definitely.
I think that profession will not go away. Like, for users, it might work for some kind of more hobbyist use cases of like, you say something and you get something roughly, that's it. And you try multiple times and it generates something else and you're happy. But for, a business or professional use case, you will need those people who will be able to guarantee that you get exactly what you want.
Yeah, I'm actually really excited about like AI can automate like part of coding, because like it's actually enables software engineers to do software much more complex. So like I go back to the analogy of writing. Like before, when you had to do the manual like copying words onto papers, like all the books back then were very small. Like I think it's like 5,000 words or 10,000 words considered like big, because like it took a long time for people to like copying things. But now like we have books like 100,000 words, right? And I think it just makes things a lot easier. I do things like with software engineering, like if you don't have to manually write code, it quickly like turn ideas into like snippets, executable programs. I do think we enable like us to write like much more complex software.
Yeah, and maybe one software engineer will be able to kind of command a lot more software, debug or maintain a lot more complex system by oneself. Because right now, there's a reason that for a million lines of code, usually there's like several engineers. It's rare to have just one engineer. If a company wrote that, I'm not talking about dependencies. So that will be interesting. So what other use cases are you excited about for that AI could bring outside of just coding?
Let's see. I think I'm excited about education. So I do things as like AI can help people learn what they want to learn a lot faster. So I think one thing I realized is that like nowadays, if you know the answers, if you know the questions, finding the answer is actually quite easy. Like you can ask like AI, and it's usually give you like a lot of, or like at least it can give you a lot of like references for you to like go and read more about it. But then like what's still hard is like how to come up with the right questions. And I think it's like education needs to like focus on like forcing students, like create the habit of like asking questions and understanding like, so I do think it's like, it is help learning to become, a lot more efficient. Like people can learn a lot of things. And I feel like I do believe that if we can learn better and faster, then we can actually do more things. So I'm very excited about like what that would look like. What other use cases I'm excited about? I'm excited about entertainment. I think it's like I think it's like sometimes we already think of like entertainment and education as separate things. But I don't see why we can't have like games that help we learn things more. Like we have some strategy games like teaching us about negotiations. That could be like really fun. Or just something like more intellectually stimulating content. Like movies or shows don't have to be like about like mindless. Like I know some people like watch that because it's help them escape. But I also think like a kind like genre is like make me think a little, like or like understand more about like different fields. So I do think that now AI can assist us in like creating content that is both entertaining and intellectually stimulating. So I think it could be like a lot of fun. For some example, it's just like nowadays we have a lot of like mediums adaptations. So you have a book, you can convert it into a movie, and sometimes you have a movie, you convert it into a game. Or like you have a papers, convert it into a podcast. So now if we have some content, AI can help us like convert, adapt different medium. That could be like very, very exciting. I think it's like there are a lot of like small problems that I'm also like interested in. I think it's like I haven't touched on any of the enterprise. I feel like that's where most money is still. I do think there's a lot of like I think like enterprise or company organization structure is going to change. So first of all, what does that mean? Like if you think about like a lot of organization, what is the job of the middle management? It's like to like first like aggregating information from their reports and transmit it like up to the executives, and this is the other way they transport it, like transmitting information like directions from executive to like lower layers. But like information aggregation is actually like really, really and something AI can be like really, really, really well. So I do think this like companies can be a lot more more efficient.
So let's close up with some rapid questions. So I'll just shoot some questions and you tell me what pops to your mind. What programming language did you use most when you built AI applications or did ML engineering, and why?
Python and JavaScript.
Ooh, JavaScript as well. How come?
Oh yeah, definitely. I think it's like a huge part of like building products when I have to like build demo quickly. So I think like that's very, very handy. I'm not very good. Like I think I've always been scared of JavaScript, but I'm very grateful like AI actually helped me like getting started a lot easier nowadays. Yeah.
And which one is your favorite LLM model right now and why?
Oof. I don't really have a favorite. I use it for different things. So I still use ChatGPT out of habit. Because I have a bunch of prompts that I use already, and I have little things like pre-built prompt for ChatGPT I'm still using. I use Claude sometimes for like creative writing. Because I think it's sometimes less cliche. I'm reading on DeepSeek R1 and who's not reading about R1, so like just trying it out. But I don't think I have like a favorite. I think I did some as a llama, lava, like which is the version of like llama before for like some kind of interesting use case, like from like screenshot to code, like just trying to test it out, having fun with it. But yeah, I'm not emotionally attached to any of them.
Yeah. And what's a neat AI tool that you've used and that you like?
So I have something that I built that's really helped me with research. So one thing is like when I saw a link like of papers, there's a lot of links and I try to get a quick. So I realized when I read a link, I do through the same process. Like I read the abstract, I look up the authors, do the written work, ask questions. I also check when it was out, check the citation. So I have the little tool that's like just like go and scan. So I have a link. You just give me all the information on like
Oh, nice. So
at a
just
high
build a
level.
tool
Yeah.
to scratch your own itch.
Yeah. So it's like I think that's the beauty of AI now. Right? You can build like it's taking you like very small amount of time. Like you just build a tool like just for you. Like before, right? It would take me like weeks. But now I can just like do all of that, like I don't know, in a few hours.
This is something to be excited about.
Yeah.
I agree with
Yeah.
that.
Yeah.
And what are one or two books that you've read and would recommend?
I recommend a lot of books, but I feel like it's recommending books when I feel like forcing people to like do what you enjoy. I like books that like help me get a new perspective, or like give me like insight into some topics I don't know a lot about. So I really like the book, like first of all, like complex adaptive systems. It's a very interesting book about like system thinking, like how to design how to design like social dynamics so that to get people to work toward like the goals that you want to work on. It's a very interesting book. Have forced you to think about systems. I like the book Selfish Gene. Because you understand more like about free will and makes you like question a little stuff. But it's the idea of like you can live on either through like genes or through ideas. Like there are two ways that you can live on. It's like, yeah, so genes continue to live on with their offsprings and like reproductions. The other thing is like if you have ideas, and the ideas can also like replicate and like go on, like the idea of memes, like genes and memes. I like the book Anti-Fragile. So the ideas thing. I think the author is a very interesting character. I actually read several of his books. Actually, I really like them. I like that book. I think there are a lot of books that I like.
No, thank you for the recommendations. So thank you for being on the podcast. I mean, AI engineering is such a new field, and it was great to hear from yourself, who has clearly gone very broad and also very deep and has been in this field even before it was called AI engineering. So thank you for this.
Thank you so much for letting me ramble on the show. I really appreciate it. And I think that I think one thing for me is I really enjoy from writing or talking is that I get feedback, because somebody was like, oh, I think I'm less interested. Like, I agree with you. I mean, it's great to hear, but it can also like a little bit like not good for the ego. But I also really like maybe a little bit pushback. Like, okay, you didn't think about this. You forgot this, or I didn't take into account this one. So I would love to get those feedback. So if there are any things that you feel like I miss out on, like, do let me know. So really appreciate it.
Thank you to Chip for this conversation about AI engineering. To get in touch with Chip, including to give feedback on her book, you can find her contact details on her website, linked in the show notes below. I've also found her book, AI Engineering, to be a broad and deep overview of this important field. It's a book that focuses on the fundamentals that are unlikely to change, so if you want to learn these, it's a good book to have. In the Pragmatic Engineer, we've previously done several AI and ML related deep dives. Check them out, also linked in the show notes below. If you enjoyed this podcast, please do subscribe on your favorite podcast platform and on YouTube. Thanks, and see you in the next one.